While the core concept of HID EVO is to connect controllers to single-access control doors, Vertex EVO's purpose is more keeping with traditional access control topology, that is, having the controller provide connectivity for multiple doors. HID EVO and Vertex EVO share the ability to communicate with the same hosts, but Vertex EVO may be a better fit in sites that have been previously wired for physical access control. The heart of a Vertex EVO installation is the EVO V1000 controller. The V1000 provides all memory and processing required for a multiple door site of up to 64 doors. The Vertex EVO V1000 controller has the identical footprint, look, and backward compatibility of the previous V1000, but with important upgrades. This Vertex EVO V1000 provides USB connectivity, 250,000 credential database capacity without need for upgrade, 100,000 event buffer, and upgraded processor and memory. Because of the power consumption of a multiple door system, the Vertex controller, unlike HID EVO, cannot be powered over Ethernet. The Vertex EVO controller must be powered by a suitable power supply with optional battery backup. Note that Vertex EVO has the capability of being powered from 12 to 24 volts DC. The V1000 is connected to the power supply here at the top of the unit. Next to the power input terminals are connections for monitoring a tamper switch, AC failure input, and battery failure input. Typically, these inputs are connected to an enclosure tamper switch and the AC failure and battery failure dry output contacts provided by the power supply. At the bottom of the V1000 is an Ethernet port that provides for connection to the host computer so that the V1000 may be configured and monitored. Also at the bottom of the V1000 are jumpers to enable or disable termination resistors for each of the 4 RS-485 ports. Details on when to enable termination resistors at the V1000 and subpanels will come later in this presentation. On either side of the V1000 is a single auxiliary input. These inputs are configurable at the host. All host configurable inputs on the V1000, as well as any of its connected subpanels, may be set up to monitor inputs that are normally open, normally closed, unsupervised, or supervised. If supervised, the inputs may be configured to operate with a range of resistor values. Also on either side of the V1000 is a single relay output. Note that unlike Edge, V1000 relays are only dry, meaning that there is no connection to any voltage potential within the controller. These Form C contacts may be used to operate external devices such as lights, sounding devices, or inputs on other equipment. On either side of the V1000 are 2 RS-485 ports. Ports 1 and 2 are on the left side of the controller, while ports 3 and 4 are on the right. These ports are how the controller communicates with its subpanels using half-duplex RS-485 connectivity. This connection is single-pair, twisted, and shielded cable that may be connected continuously for up to 4,000 feet. Up to 16 subpanels may be connected to the left side and may be distributed between ports 1 and 2 in any proportion. It is best practice to distribute subpanels on ports evenly in order to maximize fault tolerance. Each subpanel connected to the left side must be uniquely addressed using the rotary switch on the individual subpanel. The addresses are 0 inclusive, meaning that the 16 possible subpanels are addressed 0 through 15. Subpanels may be addressed in any order that makes sense to the installer, and not all addresses need to be used. The only rule that needs to be followed is that once a subpanel is addressed on either port 1 or 2, no other subpanel may use that address on either port 1 and 2. The identical scenario exists on the right side. Up to 16 subpanels may be distributed between ports 3 and 4, and addresses may not be repeated among these two ports. To the host software communicating to the V1000, the subpanels connected on the left side are referred to as addresses 0 through 15, which match their physical addresses. In order to differentiate subpanels connected to the right side of the V1000, the host software will refer to these panels as addresses 16 through 31. The software addresses of panels on the right may be calculated by adding 16 to the physical address. The 16 subpanels on either side may be any combination of V100s, V200s, and V300s. All are of the same size and bear resemblance to the V1000 controller, but are easily identified as subpanels by their rotary address switches. Each of these subpanel types has a particular function, and these subpanel types will be examined individually. The first subpanel type to be described is the V100. The purpose of the V100 is to provide connectivity for up to 2 physical access control doors. Notice that the terminal strip on top of the V100 is identical to the terminal strip on top of the V1000. These terminals provide power to the subpanel and connections to inputs for tamper, AC failure, and battery failure. If there is no need for these specific inputs, possibly because the V100 is in the same enclosure as the V1000, these inputs may be used for any other purpose. At the bottom of the V100 are the RS-485 terminals for connection to the V1000, as well as any other subpanels that are sharing the RS-485 run with the V100. Though there are 2 pairs of terminals labeled in and out, they are connected internally and are electrically identical. Also on this terminal strip is another pair of terminals labeled 12 volts DC in. These terminals are electrically identical to the similarly named terminals on top of the unit. Either set of terminals may be used to power the V100 or to feed devices connected to the unit. There is a jumper at the bottom of the V100 for enabling or disabling the termination resistor. The topic of when to enable or disable termination resistors will be covered later in the presentation. Circled here is the address selector where this subpanel's address is set 0 through 15 as discussed earlier. The first door on a V100 will be connected to its left side. The first connector, P1, is connected to the credential reader at the door. These point-to-point wires are connected identically to how a Wiegand type reader is connected to HID EVO equipment as described in the HID EVO presentation. As with HID EVO, only the first 4 wires, red, black, green, and white, are necessary to basic reader operation, while the remainder of the V100 terminals may be connected to the reader to provide optional functionality. The second connector, P2, provides connectivity for a door position switch and REX, again connected identically as a conventional door position switch and REX as discussed in the HID EVO presentation. P3 provides the door strike output relay and auxiliary output relay. These connections are similar to the outputs on HID EVO, but note that only the dry contact settings are available. Dry contacts need to be wired from a power source in order to provide power to the door components. Note that if using some magnetic locks with excessive inrush current, it is best practice to install a snubber circuit across the output contacts in order to protect them. Snubber circuits can be acquired ready-made like this one, or may be assembled in the field by connecting a 1/2 microfarad capacitor and 22 ohm half-watt resistor in series. Details are available at support.hidglobal.com. At the bottom of the V100 are RS-485 terminals for connection to the V1000, as well as any other subpanels that are sharing the RS-485 run with the V100. Though these terminals are duplicated and labeled in and out, they are connected internally and are electrically identical. Also on this terminal strip is another pair of terminals labeled 12 volts DC in. These terminals are electrically identical to the similarly named terminals on top of the unit. Either set of terminals may be used to power the V100 or to feed devices connected to the unit. There is a jumper at the bottom of the V100 for enabling or disabling the termination resistor. Again, the topic of when to enable or disable termination resistors will be covered later in the presentation. Circled here is the address selector where this subpanel's address is set 0 through 15 as discussed earlier. The V100 may be connected to a second reader on the right side. Connectors P4, P5, and P6 on the right side provide similar connectivity for the second door as P1, P2, and P3 on the left side provided for the first door. The next subpanel to look at is the V200. The V200's primary role is that of an input board. The terminal strips on the top and bottom of the V200 are identical to the top and bottom terminal strips on the V100. These connections provide power supply monitoring, and RS-485 data connectivity for the V200. Like on the V100, there is a jumper to enable or disable the resistor on the RS-485 circuit. Also, like the V100, there is an address switch for setting the V200's address 0 through 15. The V200 provides 16 host configurable inputs, 8 on its left side and 8 more on its right. Also on each side of the V200 is a single Form C relay output for operating any devices nearby. The last subpanel to look at is the V300. The V300's primary role is that of an output board. The terminal strips on the top and bottom of the V300 are identical to the top and bottom terminal strips on both the V100 and V200. These connections provide power supply monitoring, and RS-485 data connectivity for the V300. Like on the V100 and V200, there is a jumper to enable or disable the resistor on the RS-485 circuit. Also, like the other subpanels, there is an address switch for setting the V300's address 0 through 15. The V300 provides 12 Form C relay outputs, 6 on its left side and 6 more on its right. Also, on each side of the V300 is a single host configurable input for the purpose of monitoring any devices nearby. Any Vertex installation begins with the installation of the V1000 controller. The V1000 controller, as well as its sub-panels, is connected to a DC power supply, which often will include batteries as a backup source of power. The V1000 and its connected subpanels have the capability to monitor the AC failure and battery failure contacts of the power supply, as well as a tamper switch monitoring the integrity of the enclosure. Each of these inputs requires a pair of wires and may monitor either normally open or normally closed contacts. An installation may be simplified by having the controller and subpanels share an enclosure. In larger installs, subpanels may be grouped in the field in enclosures away from the V1000. The topology that provides interconnection between the V1000 and its subpanels is half-duplex RS-485. This cable is single pair, twisted, and shielded. Though not necessary, in order to promote fault tolerance, it is best practice to add subpanels evenly among the 4 physical ports on the V1000. Note that the V1000 does not need to be on the end of the run. In this drawing, the upper right RS-485 run, known as physical port 3, has the V1000 connected in the center of the run. Devices at each end of the run require termination resistors. These resistors may be enabled or disabled on each of the 4 ports of the V1000, as well as the port of each subpanel by using the jumpers on the bottom of each device. Shown here is the appropriate resistor enabling for these 4 RS-485 runs. Note that because on the upper right RS-485 run, the V1000 is not on the end of the run, the resistor is not enabled on that port of the V1000. The resistors are always enabled on the device on each end of the run. The single twisted pair cable should provide conductors marked differently so that the A and B RS-485 terminals of each subpanels can be landed appropriately. Note that it is not important on subpanels whether to use the RS-485 terminals marked out or in. Note that though the V1000 and all subpanels provide a shield terminal, in order to mitigate ground loops, it is best practice to terminate the shield of a RS-485 run in only one location. The least confusing way to achieve single-point grounding is to terminate all runs at the V1000 because that location will not change. The shield at all other connections on the run should be carried through but not connected to the shield terminal. On the end of the run, the shield should float and be taped off. A RS-485 run needs to be continuous. Unless the device is on one end or the other of the run, there will be a cable from the previous device and a cable to the next device. Each RS-485 run may be up to 4,000 feet in length. It is technically possible for 2 subpanels connected to a V1000 to be located 8,000 feet apart. A fully loaded V1000 connected to 32 V100s provides connectivity for up to 64 doors. The last Vertex EVO unit to be examined is the V2000. Essentially, the V2000 provides the functionality of a V1000 and the connectivity of a V100 in a single non-expandable footprint. The V2000 is a cost-effective, simple solution for one or two doors. To the host computer, the V2000 appears as a V1000 controller connected to a V100 subpanel. The V2000 communicates upstream to the host computer via its Ethernet port and connects to traditional door components via terminals on either side of the unit. These Vertex EVO controllers, and for that matter Edge EVO controllers, may be used to work with existing Open API systems, and when the time is right, can be made to work with the new EVO API. Thanks for attending this EVO presentation. Questions may be directed to Inside Sales or go to support.hidglobal.com.